5 key things to know about NISAR, NASA and ISRO's Earth observation satellite. Imagine a satellite so advanced it can see through clouds, track the slow creep of glaciers, and map entire forests from space, all while working in partnership with another country halfway around the world. That's the game-changing NISAR mission, a joint venture between NASA and India's ISRO. But here's where it gets controversial. Could this unprecedented collaboration set a new standard for global space partnerships, or does it raise questions about data sovereignty and international dependencies? Let's dive into 5 key facts about this groundbreaking mission, and by the end, we'll ask you a question that might just spark a debate in the comments. 1. A satellite with superpowers, 3D vision through clouds and night ***. NISAR isn't your average Earth-observing satellite. It's like a high-tech camera with night vision and X-ray capabilities. Equipped with 2 synthetic aperture radar (SAR) systems, it can detect surface changes as tiny as a fraction of an inch, even through storms or darkness. Picture a 39-foot wide radar antenna bouncing microwave signals off Earth's surface, creating detailed 3D maps of land and ice. This means scientists can monitor earthquake-prone regions 24/7, track glacier melt in real time, and even study Antarctica's ice sheets in ways never before possible. But here's the twist. While this tech is revolutionary, could its ability to see everything raise privacy concerns? We'll explore that later. 2. Disaster forecasting on steroids ***. Natural disasters don't wait for us to prepare. NISAR aims to change that. By detecting subtle shifts in Earth's crust, it can help predict landslides, volcanic eruptions, and infrastructure failures. For example, it can identify which sections of a fault line are locked and primed to slip, giving authorities critical warning time. When it comes to human-made risks, like aging dams or aqueducts, NISAR's data will help engineers assess structural integrity before cracks become catastrophes. And this is the part most people miss. The satellite's radar can also monitor soil moisture levels, which is vital for predicting floods. But here's a thought. Should this data be shared openly, or should governments control access to prevent misuse? What do you think? 3. The data monster, more than any satellite before it ***. NISAR is a data titan. Its dual radar system, a NASA-built L-band and an ISRO L-band, will generate 80 terabytes of data daily, equivalent to filling 150 hard drives every 24 hours. To put that into perspective, that's more data than all previous Earth-observing satellites combined. This is where the collaboration shines. By combining different radar wavelengths, NISAR can analyze everything from forest canopies to crop health. But here's the catch. Managing this deluge of data requires global cloud infrastructure. Does that mean relying on tech giants like Amazon or Google? Could this create new vulnerabilities? We'll ask readers to weigh in on that shortly. 4. A global ecosystem watchdog ***. Forests, wetlands, and permafrost are under threat, but NISAR's radar systems are here to help. Its L-band radar can peer through dense tree canopies to measure forest biomass, while the S-band focuses on agricultural fields and wetlands. This means researchers can track deforestation, monitor crop yields, and even study how melting permafrost releases greenhouse gases. But here's a controversial angle. While NISAR's data is publicly available, will wealthier nations use it more effectively than developing countries? Could this deepen the gap in climate action? Let's hear your take in the comments. 5. A new era of space collaboration ***. NISAR isn't just a satellite. It's a symbol of what's possible when space agencies work together. Engineers from NASA's Jet Propulsion Lab and ISRO's Ahmedabad facility designed the mission's components separately, then integrated them into a single spacecraft. This is the first project of this scale for NASA and ISRO, and it builds on decades of SAR technology evolution. From CSAT in 1978 to ISRO's RISAT missions, SAR has come a long way. But here's the question that keeps us up at night. Is this kind of international collaboration the future of space exploration, or does it risk creating dependencies that could backfire? Share your perspective below. To learn more about NISAR's mission, visit NASA's NISAR website, https://nisar.jpl.nasa.gov. And don't forget to drop your thoughts in the comments. Do you think global space partnerships like NISAR are a net positive, or do they create more problems than they solve? Launching July 30th, NASA and ISRO's NISAR satellite, Earth's new eye in the sky. Get ready for a game-changing moment in space exploration. NASA and ISRO are about to launch a mission that could reshape how we monitor our planet. Scheduled for no earlier than July 30th, the NISAR, NASA-ISRO Synthetic Aperture Radar satellite is poised to become a cornerstone of Earth observation. But here's where it gets controversial. This mission isn't just a technical marvel. It's a bold statement about international collaboration in space. With dual L and S-band radars, a first in satellite history, NISAR will map nearly 90% of Earth's land and ice surfaces every 12 days. Imagine having a 3D X-ray of our planet's surface, capturing everything from melting glaciers to shifting tectonic plates. This isn't science fiction, it's the promise of NISAR. Launched from India's Satish Dhawan Space Center on a geosynchronous launch vehicle, the satellite will deliver data that's free and open to researchers, governments, and even farmers. But here's the twist. While the mission's goals are universally praised, some critics question whether such massive data sharing could lead to unintended consequences. For example, how do we ensure sensitive geological or agricultural data isn't misused? The mission's creators argue transparency is key, but the debate is far from settled. And this is the part most people miss. NISAR's radar technology can penetrate clouds and darkness, making it a lifeline during disasters like floods or earthquakes. Think of it as a global early warning system for Earth's most vulnerable regions. Earlier this year, leaders like President Trump and Prime Minister Modi called NISAR a milestone for U.S.-India cooperation. Yet, as the launch nears, the real question lingers. Will this mission set a new standard for international space partnerships, or will it face the same geopolitical hurdles as past projects? The data will speak volumes, but the human story behind it is equally compelling. For now, all eyes are on Sriharikota as the countdown begins. Want to weigh in on whether open data policies in space exploration are a net positive? Share your thoughts in the comments. For more details, reach out to Andrew Wong at NASA's Jet Propulsion Laboratory, 626-379-6874, or andrew.wong@jpl.nasa.gov. NASA-ISRO SAR satellite, unveiling Earth's surface changes. Imagine having the ability to observe every subtle shift and transformation occurring on Earth's surface, almost as if the planet itself were posing for a high-definition portrait. That's exactly what's about to happen with the launch of a groundbreaking radar satellite. On July 30th, the NASA-ISRO SAR, NISAR, satellite will begin its mission, capturing incredibly detailed images of nearly all land and ice surfaces on Earth using synthetic aperture radar, SAR. This technology will allow scientists to detect ground movements as tiny as a single centimeter, providing an unprecedented level of insight into our planet's dynamic exterior. But here's where it gets exciting. This isn't just about taking pretty pictures. From dense forests to icy glaciers, from coastal wetlands to frozen tundras, researchers will now have access to data that can help them better understand the forces driving changes in Earth's landscapes, and how these shifts are connected to the escalating global climate crisis. For instance, what role does melting permafrost play in releasing greenhouse gases? How do deforestation and urbanization impact natural water cycles? These are some of the critical questions NISAR aims to address. Among those eagerly awaiting the satellite's deployment is Rowena Lohman, a professor of Earth and Atmospheric Sciences at Cornell Engineering. As part of the project team, she is overseeing efforts to collect soil moisture data, a task perfectly aligned with her expertise in interferometric synthetic aperture radar, NISAR. NISAR works by combining two radar images of the same area to detect minute changes in elevation or movement. Early in her career, Lohman used this technique to study seismic activity, analyzing the subsurface displacements that lead to earthquakes. More recently, however, her focus has shifted toward understanding groundwater extraction and its effects on surface stability. My work often involves refining techniques to filter out noise so we can detect smaller signals, she explains. For example, when observing ground deformation, variations in soil moisture can introduce interference. What might seem like noise to one researcher could actually be valuable data for another. This duality underscores the versatility of NISAR's dual-band radar system, which operates using both L-band, 25-centimeter wavelength, and S-band, 10-centimeter wavelength, instruments. Different scientific communities utilize the same datasets in unique ways. Soil moisture experts, for instance, measure how reflective the surface appears and track changes over time, a crucial metric for predicting weather patterns and managing agricultural resources. Meanwhile, specialists in ground deformation analyze alterations in the phase of radar signals to identify even slight shifts in the terrain. According to Lohman, collaborating across disciplines has been eye-opening. It's fascinating to see how other researchers approach the same data differently, she says. There's so much potential for cross-pollination of ideas. One reason why NISAR is such a powerful tool lies in its ability to penetrate clouds and operate in darkness, conditions that typically hinder traditional optical imaging methods. Additionally, NISAR's frequent revisits to the same locations, every 6 days for most areas, will yield more consistent observations than ever before. This is especially important for vegetated regions, where shorter wavelengths tend to scatter and distort the signal. The mission also promises significant advancements in spatial resolution for soil moisture measurements. While previous global estimates averaged data over several kilometers per pixel, NISAR will refine this to an impressive 200 meters per pixel. Such granularity will benefit a wide range of applications, from short-term weather forecasting to long-term drought monitoring and flood preparedness. Consider this scenario. A storm is approaching Montana, and emergency managers need to predict which dams downstream might overflow. Knowing the current soil moisture levels is essential because dry soil absorbs more water, mitigating flood risks. Conversely, saturated soil exacerbates flooding by allowing excess water to flow unchecked. Similarly, in the Arctic, NISAR's capabilities could revolutionize our understanding of permafrost thawing, a process with profound implications for climate change. Historically, studying the Arctic has been challenging due to noisy radar signals. However, NISAR's longer wavelengths and higher stability will enable clearer observations of this rapidly changing region. I think we're going to uncover things we never expected, Lohman predicts. The Arctic is undergoing dramatic transformations, and NISAR could provide insights that transform our understanding of these ecosystems. Scheduled to lift off from the Satish Dhawan Space Center in Sriharikota, India, the satellite's primary mission is set to last 3 years, though it may continue operating far beyond that time frame. Once operational, certain radar readings will be validated through fieldwork conducted by volunteers worldwide. Within approximately 36 hours, all collected data will be uploaded to the Amazon cloud, making it freely accessible to anyone interested, from curious students to seasoned climatologists, as part of NASA's commitment to open-source science. As the countdown to launch progresses, Lohman and her colleagues are immersed in rigorous testing and calibration procedures to ensure the accuracy of the satellite's measurements. Despite the immense pressure, Lohman remains optimistic. What keeps me up at night? Honestly, it's figuring out how to handle the sheer volume of data we'll receive, she admits. But that's a good problem to have. We're talking about petabytes of information, and NASA is dedicated to sharing it openly. I truly believe the scientific community will find innovative ways to leverage this resource. So what do you think? Will NISAR live up to its promise of transforming how we monitor Earth's environmental health? Or are there challenges ahead that haven't been fully considered? Share your thoughts in the comments below.